Imagine a place so powerful, so mysterious, that it shapes the very fabric of the universe around it. A place where gravity reigns supreme, bending light, warping time, and holding entire galaxies together. This is the realm of supermassive black holes, cosmic giants lurking at the hearts of galaxies, including our very own Milky Way. Today, we're diving deep into the enigma of these incredible objects, what they are, how they form, and why they matter to everything we know about the cosmos. Buckle up, because this is going to be a wild ride through space and time. We're not just talking about distant phenomena here. These are forces that have shaped the universe since its earliest days, and they continue to influence the stars we see every night. Let's start with the basics. A black hole is a region in space where gravity is so intense that nothing, not even light, can escape its pull. It's a concept that sounds like science fiction, but it's very real. Now, supermassive black holes, they take this idea to an entirely different level. These aren't your average black holes formed from the collapse of a single star. No, supermassive black holes are behemoths, with masses ranging from hundreds of thousands to billions of times that of our sun. To put that into perspective, if our sun were the size of a basketball, a supermassive black hole could be as large as an entire city, or even a small country. That's the kind of scale we're dealing with here. Scientists believe that nearly every large galaxy has one of these giants at its center. Take the Milky Way, for example. Right at its heart, about 26,000 light years from Earth, lies a supermassive black hole called Sagittarius A for short. It's estimated to have a mass equivalent to 4.3 million suns, all packed into a region smaller than our solar system. That's mind-boggling density. But how do we even know it's there if we can't see it? The answer lies in the dance of the stars. Astronomers have spent decades watching stars near the galactic center zip around at incredible speeds, some moving at over 3 million miles per hour. These orbits can only be explained by the presence of an enormous invisible mass pulling them in. That mass, Sagittarius A*. In 2022, the Event Horizon Telescope gave us the first ever image of this black hole's shadow, a glowing ring of gas and light bent by its gravity. It was a historic moment, proving beyond doubt that supermassive black holes aren't just theoretical, they're real, and they're shaping our universe. So where do these cosmic titans come from? That's one of the biggest questions in astrophysics, and the answer isn't simple. Let's explore a few leading theories. First, there's the idea that supermassive black holes grow from smaller seed black holes. These seeds could form when massive stars, dozens or even hundreds of times larger than our sun, run out of fuel, collapse under their own gravity, and become stellar mass black holes. Over time, these smaller black holes could merge with others or gobble up surrounding gas, dust, and stars, growing into the supermassive monsters we see today. It's a slow, steady process of accumulation, like a snowball rolling downhill, picking up more and more mass as it goes. But here's the catch. This process takes time. Billions of years, in fact. And yet, astronomers have found supermassive black holes in galaxies that formed just a billion years after the Big Bang. How could they grow so fast? This leads us to another theory, direct collapse. In the early universe, massive clouds of gas, hundreds of thousands of times more massive than the sun, might have collapsed directly into black holes without ever forming stars first. These direct collapse black holes would start big, giving them a head start to become supermassive in a shorter time. Imagine a cosmic shortcut, skipping the slow growth phase entirely. There's also a wild card, primordial black holes. Some scientists suggest that tiny black holes could have formed in the chaotic moments after the Big Bang due to fluctuations in the density of the universe. If some of these stuck around and grew by consuming matter, they might have evolved into the supermassive black holes we see today. These primordial seeds could have been scattered across the early universe, waiting to grow into giants. The truth? We don't know yet. It's likely a mix of these processes: stellar seeds, direct collapse, and maybe even primordial origins. Each discovery brings us closer to cracking the mystery, but for now, it's a cosmic puzzle with pieces still missing. Now let's talk about what these black holes do. Supermassive black holes aren't just sitting quietly at the centers of galaxies. They're active players in the cosmic game. When matter falls toward a black hole, it doesn't just vanish. It forms a spinning disk of gas and dust called an accretion disk. As this material spirals inward, it heats up to millions of degrees, emitting intense radiation, X-rays, gamma rays, and more. This is why some galactic centers glow so brightly, we can see them from billions of light years away. It's not the black hole itself we're seeing, but the chaos it creates around it. But it gets even more dramatic. In some cases, supermassive black holes launch colossal jets of energy, streams of particles moving at nearly the speed of light, stretching thousands of light years into space. These jets are powered by the black hole's immense gravity and magnetic fields, and they can influence entire galaxies. Take quasars, for example. These are among the brightest objects in the universe, powered by supermassive black holes gobbling up matter at a ferocious rate. Some quasars outshine their host galaxies by a factor of 1,000. They're like cosmic beacons, visible across vast distances, telling us about the universe's wild youth. These active black holes, often called active galactic nuclei, or AGN, don't just light up the sky, they shape their surroundings. Those jets can heat up gas in a galaxy, preventing it from cooling and forming new stars. In a way, supermassive black holes act like cosmic thermostats, regulating star formation and keeping galaxies from growing too fast. It's a delicate balance. Too much activity, and a galaxy might stop evolving. Too little, and it could spiral out of control. This power makes them not just objects, but forces of nature that dictate the life cycles of galaxies. This brings us to a fascinating connection. Supermassive black holes and the galaxies they live in seem to grow together. Astronomers have found a striking relationship between the mass of a supermassive black hole and the mass of its galaxy's central bulge, the dense region of stars around it. The bigger the bulge, the bigger the black hole. This isn't a coincidence. It suggests that black holes and galaxies co-evolve, influencing each other over billions of years. It's a partnership written in the stars, or rather in the gravity that binds them. How does this work? One idea is feedback. When a supermassive black hole feeds on matter and blasts out energy, it can push gas away from the galaxy's center. This feedback process can slow down star formation, keeping the galaxy in check. Over time, the black hole's growth and the galaxy's development sync up. It's almost as if they're in a cosmic dance, one leading, the other following, but both shaping the rhythm of the universe. The black hole grows by consuming material, while the galaxy adjusts its structure in response to the energy released. Take the Milky Way as an example. Sagittarius A* is relatively quiet now, but it wasn't always that way. Billions of years ago, it might have been a quasar, lighting up the sky as it consumed vast amounts of material. Today, it's in a dormant phase, but its past activity likely helped sculpt the galaxy we call home. This interplay is a key piece of the puzzle in understanding how galaxies like ours came to be. It's not just about the stars or the gas, it's about the invisible giant at the center, pulling the strings behind the scenes. What's next for these cosmic giants? Well, the universe is a dynamic place. Galaxies collide and merge all the time, and when they do, their supermassive black holes get closer too. Over millions or billions of years, these black holes can spiral toward each other, eventually merging into an even larger black hole. When this happens, it sends ripples through space-time, gravitational waves, that we can detect here on Earth. It's like the universe ringing a bell, and we're just learning how to listen. In 2015, the LIGO Observatory made history by detecting gravitational waves from the merger of two stellar mass black holes. But supermassive black hole mergers, those are on a whole different scale. Scientists are working on projects like the Laser Interferometer Space Antenna, or LISA, set to launch in the 2030s. LISA will listen for the low-frequency waves from supermassive black hole mergers, giving us a front-row seat to some of the universe's most epic events. These collisions are rare, but they're monumental, reshaping galaxies and rewriting the cosmic map. And what about Sagittarius A*? In about 4 billion years, the Milky Way is expected to collide with the Andromeda Galaxy. When that happens, our black hole and Andromeda's supermassive black hole will eventually meet. The result? A new, even more massive black hole at the center of a combined galaxy. It's a slow process, unfolding over eons, but it's a reminder that the universe is always changing, and supermassive black holes are at the heart of that change. What we see today is just a snapshot in a story that's still being written. So why should we care about supermassive black holes? For one, they're a window into the past. By studying them, we learn about the early universe, the birth of galaxies, and the forces that shaped everything we see today. They're like time capsules, preserving clues about the cosmos's wild beginnings. They also challenge our understanding of physics. How do gravity, quantum mechanics, and the fabric of space-time behave near a black hole? These are questions that push the boundaries of science, forcing us to rethink what we believe is possible. But beyond the science, there's something awe-inspiring about supermassive black holes. They remind us of our place in the cosmos, tiny specks in a vast, mysterious universe. They're a testament to nature's power and complexity, sparking curiosity in everyone from astronomers to dreamers gazing at the night sky. They connect us to something bigger, something beyond our everyday lives, and that's a feeling worth holding on to. Supermassive black holes are more than just objects. They're architects of the universe, sculpting galaxies, bending reality, and holding secrets we're only beginning to uncover. They've been here since the dawn of time, guiding the growth of the cosmos, and they'll be here long after we're gone, shaping what comes next. The next time you look up at the stars, think about the invisible giant at the heart of our galaxy, silently pulling the strings of the cosmic show. This is the story of supermassive black holes, and it's far from over. So what do you think? Are you ready to explore more of the universe's mysteries?